When dealing with electrical installations, specifically concerning parallel feeders from the service disconnect to the main distribution panel, it's crucial to adhere to the National Electrical Code, or NEC. The question arises whether these parallel feeders can be housed within the same conduit. According to the NEC, the answer is yes, provided certain conditions are met. NEC Article 310.15b3 addresses this directly. This section generally permits conductors of the same circuit, including grounding conductors, to be run together in the same raceway or cable, or even in different raceways or cables, as long as they extend between the same points. This allowance is subject to specific stipulations outlined within the code. One important exception to consider is listed in Article 310.15b3. This exception allows conductors of the same circuit size to be grouped together in a raceway, provided the allowable ampacity of the raceway is not exceeded. Ampacity refers to the current carrying capacity of a conductor in amps. It's the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. When multiple conductors are installed in a single conduit, the ampacity of each conductor may need to be derated. Derating factors are applied because the heat generated by multiple current-carrying conductors in close proximity can raise the overall temperature within the conduit, potentially damaging the insulation of the conductors and reducing their current-carrying capacity. These derating factors are specified in the NEC and are based on the number of current-carrying conductors in the raceway and the ambient temperature. In the specific scenario where parallel feeders are of the same circuit size, they are permitted to be run together in the same conduit if they are within the allowable ampacity of that conduit. This means that the combined current of the parallel feeders, after applying any necessary derating factors, must not exceed the maximum current carrying capacity of the conduit. Several factors determine the allowable ampacity of a conduit. Firstly, the size and type of the conduit itself are important. Different conduit materials, such as PVC, rigid metal conduit, or electrical metallic tubing, have different thermal properties and therefore different ampacity ratings. Secondly, the temperature rating of the conductors used is a key consideration. Conductors are typically rated for maximum operating temperature such as 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The ampacity of the conductor is based on this temperature rating and the ambient temperature in which the conduit is installed. Thirdly, the number of current-carrying conductors within the conduit is crucial, as this affects the amount of heat generated and the need for derating. To determine whether the parallel feeders are within the allowable ampacity of the conduit, several steps are necessary. Firstly, determine the total current that the parallel feeders need to carry. This is based on the load that the feeders are serving and any applicable demand factors. Secondly, select the appropriate size and type of conductors for the parallel feeders, ensuring that they have an ampacity rating that is adequate for the load. Thirdly, calculate the derating factors that need to be applied based on the number of current-carrying conductors in the conduit and the ambient temperature. Fourthly, apply the derating factors to the ampacity of the conductors to determine their allowable ampacity in the conduit. Fifthly, compare the allowable ampacity of the conductors to the total current that the parallel feeders need to carry. If the allowable ampacity is greater than or equal to the total current, then the parallel feeders are within the allowable ampacity of the conduit and are permitted to be run together. It's important to note that the NEC provides specific tables and guidelines for determining ampacity ratings and derating factors. These tables are based on extensive testing and engineering analysis and are designed to ensure the safety and reliability of electrical installations. Some additional considerations when running parallel feeders in the same conduit are: firstly, ensure that all conductors are properly identified. This includes marking the phase conductors, neutral conductors, and grounding conductors with the appropriate colors or markings. Secondly, make sure that all connections are made properly and are adequately sized for the current that they will be carrying. This includes using appropriately sized connectors and terminals and ensuring that they are properly torqued. Thirdly, inspect the conduit and conductors for any signs of damage or deterioration. This includes checking for cracks, abrasions, or corrosion. If any damage is found, the conduit or conductors should be replaced. Fourthly, consider the physical protection of the conduit. If the conduit is exposed to physical damage, it should be protected by a barrier or other means. This is particularly important in areas where there is a risk of impact from vehicles or equipment. Fifthly, ensure that the conduit is properly supported. Conduit should be supported at regular intervals to prevent them from sagging or becoming damaged. The NEC specifies the maximum spacing between supports for different types of conduit. Sixthly, consider the routing of the conduit. Conduit should be routed in a way that minimizes the risk of damage or interference. They should be kept away from sources of heat, moisture, and corrosive substances. They should also be routed in a way that allows for easy access for maintenance and repairs. Seventhly, document the installation. Keep a record of the conduit size, type, and location, as well as the size and type of conductors used. This will be helpful for future maintenance and repairs. In summary, the NEC permits parallel feeders from the service disconnect to the main distribution panel to be run in the same conduit, provided that they are of the same circuit size, are within the allowable ampacity of the conduit, and comply with all other applicable requirements of the code. Adhering to these regulations ensures a safe and compliant electrical installation. Always consult the latest edition of the NEC and local electrical codes for specific requirements and interpretations. Also, it is recommended to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable requirements. Factors such as ambient temperature, the type of insulation on the conductors, and the presence of other heat-generating equipment can also affect the allowable ampacity of the conductors. Therefore, it is essential to consider all relevant factors when determining the appropriate size and type of conductors for a particular application. Moreover, when installing parallel conductors, it is important to ensure that all conductors are of the same length, material, and insulation type. This helps to ensure that the current is evenly distributed among the conductors and that there are no imbalances that could lead to overheating or other problems. Additionally, the NEC requires that all parallel conductors be terminated in the same manner. This means that they must be connected to the same terminals or lugs and that the connections must be made with the same torque specifications. This helps to ensure that the connections are secure and that there is good electrical contact between the conductors and the terminals. Furthermore, when running parallel conductors in a conduit, it is important to ensure that the conduit is properly sized to accommodate all of the conductors. The NEC provides tables that specify the maximum number of conductors that can be installed in a particular size of conduit. These tables take into account the size of the conductors, the type of insulation, and the fill ratio of the conduit. It is important to comply with these requirements to prevent overheating and other problems. When calculating the ampacity of conductors in a conduit, it is important to consider the ambient temperature. The ambient temperature is the temperature of the air or other medium surrounding the conduit. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides tables that specify the ampacity correction factors that must be applied to account for the ambient temperature. These correction factors are based on the type of insulation used on the conductors and the ambient temperature. It is also important to consider the presence of other heat-generating equipment near the conduit. Heat from other equipment can raise the temperature of the conduit and reduce the ampacity of the conductors. In these cases, it may be necessary to install the conduit in a separate location or to provide additional ventilation to dissipate the heat. When installing parallel conductors, it is important to ensure that the conductors are properly supported and secured. The NEC specifies the maximum spacing between supports for different types of conduit. It is important to comply with these requirements to prevent the conduit from sagging or becoming damaged. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for the installation of the conductors and conduit. The manufacturer's instructions may provide additional information and guidance that is not covered in the NEC. It is also important to consider any local codes or regulations that may apply to the installation. Local codes may have more stringent requirements than the NEC. It is important to comply with all applicable codes and regulations to ensure a safe and compliant installation. Always consult with a qualified electrical contractor or engineer if you have any questions or concerns about the installation of parallel conductors. A qualified professional can help you to ensure that the installation is safe, compliant, and meets your specific needs. Understanding and adhering to these NEC guidelines and best practices is essential for ensuring the safety and reliability of electrical systems involving parallel feeders in conduits. The proper installation and maintenance of these systems are crucial for preventing electrical hazards and ensuring the efficient operation of electrical equipment. Remember that electrical work can be dangerous, so always take the necessary precautions and consult with qualified professionals when needed. By following these guidelines, you can help to ensure that your electrical installations are safe, compliant, and reliable.